Hello and welcome to today's lesson, the final lesson in the electricity topic, other than the practicals that we will do when we return to school. So today's lesson is all about the national grid. So to start with, I'm going to play the short video from the National Grid's website, all about what they do. So there you have it. In a nutshell, the national grid is the system of transporting electricity and also gas around the country. The national grid is nothing to do with, well, it is something to do with, but it's not the power stations themselves, and it's not the end bit, so all the kind of cables into your home. All of that is the suppliers. So my electricity is with the Green Energy Network. You can also go with British Gas. You can go with E.ON. There's loads of companies. But the National Grid is a separate company that deals with transporting electricity and gas, although we're only going to look at the electricity. So here are two maps that I took off their website. You can see that there's a massive network around the country of gas overhead lines for electricity. Now, obviously, there's even more, but these are the main ones. And you can see that it even extends between our country and other countries. So under the sea, there's these huge cables that go to Ireland, that go to France, that go to Denmark and Norway. And sometimes we send electricity to other countries, and sometimes other countries send electricity to us. Now, you might have seen in the news recently something really amazing has happened over the past month, May 2020. It's the first month for a very long time that we've used no coal electricity. So there's a really, really good website that I want to show you that really explains or shows you the electricity that we use. It's this website here. It's called Gridwatch .templar.co.uk. If you just search Gridwatch in Google, there's about 3 or 4 websites. This is my favorite. It gives you so much information. It tells you just how much electricity we need each day. It tells you what the frequency is, and from our lesson on mains electricity, you know it's 50 hertz. It is actually very, very slightly higher than that, but you can see it never really varies much. And then it tells you what percentage we get from all different sources. So you can see that one of our biggest sources is coal. Sorry, not coal, gas, with about 32%. One of our next biggest sources is wind, 24%. That's massively increased over the past few years. Nuclear is also pretty big with about 17. Solar varies a huge amount. When I checked yesterday in the middle of the day, this was about 30%. Today now it's about 5%. That's because I'm recording it at sort of 9 o'clock or 10 o'clock in the morning. So it's obviously not that sunny and it's quite cloudy today, so solar is a lot lower. And then we also have biomass. So this is a mixture of burning wood from trees that are being burnt, and also things like methane generated from landfill sites. This is all biomass. Now, what you can also see here is that we are importing some of our electricity from France as well. If you click here, it actually tells you all about France. So France is really interesting. I'll just show you this briefly because France is almost all green electricity. It's about 70% nuclear, 20% hydro, and a few other bits and pieces. They have so much nuclear and hydroelectricity that they're really, really green, whereas we're not quite there yet. The last things I want to show you are these graphs here. So some of the questions that you'll get, so this is made sort of in the year 9 topic for energy, but it's still going to be on paper 1, is what happens to the demand for electricity, over the day. So this graph here, you can see what happens over, day and night. Obviously, there is a dip at nighttime when we use electricity. What about over the week? Well, you can see that there's this massive dip here. Where do you think the dips are? The dips are at nighttime. And you can see that also at the weekend, there's a little dip. Why do you think there's a dip at the weekend? Well, things like factories and schools don't usually run at the weekend, so there's a lot less electricity needed. Month is also interesting because you can see there's certain dips. Where do you think the dips are? Well, the dips are usually in the summer where we don't need to put our heating on. For example, that's most easily seen over the yearly demand. Here, April, May, June, July, where it's summer, we use a lot less electricity than in the winter. Now, I'm not sure if it's shown super well on here, but actually, since the lockdown because of the coronavirus pandemic, actually our demand has gone down by quite a lot, which is a good thing for the environment. Usually it's maybe like 10, 20% higher, but because we're all at home, factories aren't running, it's been a lot lower recently. So I'd really encourage you to look at this website. You can also see here how different types of energy vary. Solar, of course, is interesting. You can look at solar at peaks during the middle of the day, goes to 0 during the night, which means that could we power our whole country on solar electricity? Well, no, of course we couldn't, because nighttime we don't get any. So you need a mixture of energy sources to generate sustainable electricity. So it tells you some information about all of these types. So this is a really good website for revision and just for learning. So let's go back to the PowerPoint. So what is the national grid? So the national grid, as we said, is this system of cables that transports electricity around the country. It also transports gas, but we're not really going to talk about that. So you'll see diagrams like this, and you need to really know the main steps. You need to know that obviously electricity is generated at a power station, so that could be renewable or non-renewable. This generates electricity at 25,000 volts-ish. It goes to this thing called a step-up transformer. It goes through transmission cables at a really high voltage, maybe 700 kilovolts. It can be a bit higher, a bit lower. It then goes down through this thing called a step-down transformer, turns into 230 volts, which is what we use in our homes. If it's factories use something different. They might use 400 volts. Some of them might use 11,000 volts, but it's obviously a lot lower than these cables. So here's the information summarized for you to make some notes. Importantly, this last bullet point shows you the sheer amounts of energy we're using. Okay, so this unit here, the megawatt, is very common. So this is the end of the first part of the video, and the next part of the video we will look at transformers in more detail.